So I'm doing problem 11, which is a person doing a chin-up weighs 700 newtons, exclusive of the arms. During the first 25 centimeters, each arm exerts an upward force of 355 newtons. If the upward movement starts from rest, what is the person's velocity? So I wrote, instead of doing the diagram as usual, I just wrote out the given information because I think it'll be easier to understand what I'm solving for if I just list out the givens. So I have the person weighing 700 newtons. I have the delta x being 25 centimeters, which is actually 0.25 meters. And then each arm exerts an upward force of 355 newtons. It says starts from rest, so its initial velocity equals 0 meters per second. I'm solving for final velocity. And to do that, first I have to do sum of the forces equals mass times acceleration. So I got it here, 2 times the upward force from each arm. You have two arms, so that's why it's multiplied by 2. And then minus the weight force equals mass times acceleration. So you have, again, the same details on the left side, but then for the mass, I just get 700 newtons equals mass times gravity. We know gravity is 9.8 meters per second squared. We can solve m by getting 500 over 7 kilograms. That's where we plug it in here. And then we get 710 newtons minus 700 newtons equals 500 over 7 kilograms times acceleration. We get 10 newtons equals 500 over 7 kilograms times acceleration. And that turns out to be 7 over 50 meters per second squared. Mr. Greenberg was mentioning about a kinematics equation, so this is where it comes into hand. So it'll be final velocity squared equals initial velocity squared plus 2 times acceleration times delta x. We get final velocity squared equals 0 meters per second squared, which is, we'll just cancel out, plus 2 times the acceleration, 7 over 50 meters per second squared, times 0.25, which is the centimeters to meters. And then we get Vf squared equals 7 over 100 meters squared over second squared. When we square root both sides, we get this as the final velocity, 0.265 meters per second. And that's your answer.